9 electric rope shovels, ranked from the first machine that proved cable-fed electric power could outdig steam, up to the single largest mining shovel ever built. Each one solved a different mine's problem: harder rock, deeper overburden, or sheer volume that no smaller machine could keep up with. By the end, you'll see the dipper that dwarfs everything that came before it, built for a handful of mines that needed something no other shovel could deliver. Long before hydraulics or diesel power took over surface mining, shovels ran on electricity pulled straight from overhead cable, and the Bucyrus-Erie 50B was one of the machines that proved the idea worked at scale. Built starting in the 1920s, it replaced steam boilers and coal-fired engines with electric motors driven by a trailing cable, cutting weight and letting operators run the machine for entire shifts without refueling. It went to work on the iron ranges of Minnesota and the early strip mines of Appalachia, loading rail cars one bucket at a time. Every giant electric shovel built after it, all the way up to the machine at the end of this list, descends from this basic layout. The 50B carried a dipper of about 2 cubic yards, small by the standards of what came later, but enormous compared to the steam shovels it replaced. It weighed close to 85 tons, light enough to be shipped in pieces by rail and reassembled on site, which mattered when mines were opening in places with no roads built for anything bigger. Crowd force, the push that drives the dipper into the bank, came from a rack and pinion system geared low for reliability rather than raw speed. What made the numbers work was consistency. An electric shovel could dig the same bank at the same rate, shift after shift, in a way steam shovels never quite matched. Mines running the 50B reported it working for decades after installation, long past when a comparable steam machine would have been scrapped. Stood next to a person, the 50B's dipper alone stood taller than an average adult, and the machine's boom reached higher than a 2-story building. Overall, it measured around 9 meters long and stood roughly 7 meters tall at the boom point, modest next to later giants, but already dwarfing the horse-drawn scrapers it replaced. By the middle of the 20th century, the Marion Power Shovel Company had scaled up the same electric formula into a machine built for continuous coal and iron production, and the 4161M became one of its signature large shovels. Marion built these for mines across the American Midwest and Appalachia, where seams ran deep enough that a bigger dipper meant fewer passes and faster trains loaded per shift. The 4161M wasn't the biggest machine Marion ever built, but it was the size mines actually bought in numbers, because it matched the throughput a typical strip mine needed, without the extra cost of an oversized giant. Operators trained on this class of shovel for years before moving up to anything larger. The 4161M swung a dipper in the 6 to 8 cubic yard range, roughly triple what the earliest electric shovels carried a generation before. Operating weight came in around 300 tons, still light enough to move between pits on standard crawler tracks without special transport. Its crowd and hoist motors ran in the range of several hundred horsepower each, sized so the machine could dig through mixed rock and clay without stalling mid-cut. The real advantage showed up in cycle time. A good operator could swing, dump, and return for another bite in under 30 seconds, which is what let a machine this size outproduce shovels twice its weight, built a decade earlier. Mines valued it enough that some 4,461M units stayed in service for over 30 years. Set beside a mine worker standing on the ground, the 4161M's tracks alone rose over head height before the machine's body even began. It measured close to 17 meters long and stood about 11 meters tall, big enough that the operator's cab sat higher than a 3-story building. Look at the long arm running from the machine's body out to the dipper, and you're looking at the rack and pinion crowd system that set Marion shovels apart. Instead of a cable pulling the dipper into the bank, a geared rack physically pushed it forward, giving the operator more direct control over how hard the bucket bit into the rock. That mechanical crowd is why Marion shovels earned a reputation for digging through harder ground than cable crowd competitors of the same size. By the 1990s, Harnisch-Fager's P&H division had turned the 2800 into the default mid-size electric shovel for mines that needed serious tonnage without committing to a machine the size of a building. The 4800XPC refined decades of P&H shovel design with AC drive motors and computer-monitored controls, replacing the DC systems and analog gauges older operators had grown up with. It became one of the most widely sold large shovels in the world, working copper pits in Chile, coal mines in the American West, and iron ore operations in Australia, often several units at a single site. Its popularity came less from being the biggest machine available, and more from being the size that made the most economic sense for a typical large open pit. The 4800XPB carries a dipper between roughly 22 and 33 cubic yards, depending on how a mine configures it for its specific rock density. Operating weight runs close to 660 tons, which needs specialized heavy-haul trailers to move between sites, but is routine for modern mine logistics. Its AC drive system delivers somewhere around 3,000 horsepower combined, across hoist, crowd, and swing motors, a jump that let it dig harder ground faster than the DC-driven shovels it replaced. A single well-run 2800XPB can load a 240-ton haul truck in 3 to 4 passes, keeping a fleet of trucks running on a tight cycle instead of waiting on the shovel. That efficiency is why so many mines standardize their fleets around this one model instead of mixing shovel sizes. Parked next to a mine haul truck, the 2800XPB's dipper alone can hold more rock than a large pickup truck bed could carry in 20 trips. The machine measures around 20 meters long and stands close to 15 meters tall enough that its boom clears a 4-story building. Bucyrus-Erie built the 295B to compete directly with Marion's large shovel line, and through the 1960s and 70s, it became a fixture of the biggest coal strip mines in the American West and the iron ranges of the upper Midwest. It represented a real jump in scale from the shovels of the previous generation, built for mines that had moved from underground room and pillar operations to enormous open pits, where a slow shovel meant idle trucks and lost production. Bucyrus engineered the 295B with an emphasis on raw digging force over speed, aimed at mines fighting through harder overburden than the softer ground earlier shovels were designed for. The 295B swung a dipper in the 15 to 27 cubic yard range across its configurations, more than triple the capacity of a Marion 461M working the same era. Operating weight climbed to roughly 700 to 800 tons, a jump that forced mines to reinforce haul roads and benches just to support the machine's ground pressure. Its motors delivered well over 2,000 horsepower, and the added crowd force let it break through cemented overburden that had stalled smaller shovels. One documented case at a Wyoming coal mine had a 295B running continuously for over 20 years across 3 shifts a day, a service life that justified its high upfront cost many times over. That kind of return is exactly what pushed mine operators toward bigger machines instead of running more small ones. Standing beside its own crawler track, a person barely reaches the top of the tread before the machine's body even starts. The 295B measured close to 24 meters long and stood about 18 meters tall at full boom height, roughly the height of a 6-story building. Marion pushed its large shovel line further with the 191M, built for the wave of western coal mines that opened through the 1970s in Wyoming's Powder River Basin and similar basins where seams ran wide and shallow, but overburden ran deep. Mines here needed a shovel that could move enormous volumes of dirt just to expose the coal underneath, so the 191M was sized specifically for that stripping job, rather than for loading coal itself. It became one of the largest conventional shovels Marion put into regular production, and a handful of units earned a kind of local fame among the crews who ran them for entire careers. The 191M carried a dipper in the 30 to 45 cubic yard class, nearly double what a 295B could manage, built specifically to move overburden efficiently rather than dig hard rock. Operating weight reached close to 1,000 tons, a figure that meant the shovel effectively became a permanent fixture of a pit, moved only when the mining plan required it, and never for anything short of that. Its total installed horsepower crossed 3,000, split across separate motors for hoist, crowd, swing, and propel, each with its own control loop so the machine's computer could balance load across all 4 at once. Getting a shovel this size to a mine site was its own project. Crews disassembled it into dozens of truckloads, then spent weeks reassembling it on site before it ever swung its first bucket. Once running, a 191M could move volumes of overburden that would have taken 2 or 3 smaller shovels working around the clock. Walk up to a 191M, and the crawler tracks alone stand taller than a loaded pickup truck stacked on its roof. The shovel measures roughly 28 meters long and stands about 20 meters tall, close to the height of a 7-story building. P&H's 4100 series marked the point where electric rope shovels crossed into a size class built specifically for the largest open-pit mines on Earth: copper operations in Chile and Arizona, iron ore in Australia, and coal basins that needed shovels working around the clock for decades. The 4100A, an early standard production version of that line, set the template later XPB and XPC variants would refine, rather than reinvent. Mines chose it because at this scale, a shovel isn't just digging, it's setting the pace for an entire fleet of haul trucks, and a machine that digs even slightly faster changes the economics of the whole operation. The 4100A handled dippers from roughly 33 up to 56 cubic yards, depending on rock density and truck fleet size at a given mine. Operating weight sat around 1,300,000 pounds, close to 650 tons, requiring purpose-built heavy haul equipment just to relocate it between pits. Combined drive power crossed 4,000 horsepower, distributed across separate AC motors for each major function, letting the control system respond to variable rock conditions bucket by bucket instead of running at one fixed setting. At full capacity, a 4100A could fill some of the largest haul trucks in the world in as few as 3 passes, keeping truck cycle times tight, even on long-haul routes. That kind of throughput is why this shovel size became the standard purchase for new megamines opening through the 1990s and 2000s, rather than a specialty option. Next to a mine haul truck with tires taller than a person, the 4100A's dipper can still fill that truck's entire bed in just a few scoops. The shovel measures about 26 meters long and stands close to 17 meters tall, roughly level with a 5-story building. When Caterpillar acquired Bucyrus International in 2011, it inherited a shovel line that had already earned a reputation as some of the largest mining equipment ever put into regular production, and the 495HD sat near the top of it, later rebadged as the CAT 7495HF. Bucyrus built this class for operations where overburden ran so deep that anything smaller would need double the machines to hit production targets. Most notably Alberta's oil sands, where the material being moved is lower density than hard rock, and mines compensate by moving far greater volumes of it. The rebadging under Caterpillar changed the paint and the parts network, but kept the underlying engineering that had already made this shovel class a benchmark. The 495HD's dipper ranges from about 56 up to 73 cubic yards, sized deliberately large because oil sands material is lighter per cubic yard than typical hard rock overburden, so the shovel needs more volume to move an equivalent tonnage. Operating weight reaches around 1,470,000 pounds, close to 735 tons, putting it in a class only a handful of mine sites in the world are set up to support. Total drive power crosses 5,000 horsepower across its hoist, crowd, and swing systems, engineered to keep cycle times fast, even while moving that much material bucket after bucket. In continuous oil sands operation, a shovel this size can move over 100,000 tons of material in a single day, when paired with a matched fleet of the largest haul trucks built. That combination of shovel and truck fleet size is effectively what makes a modern oil sands mine possible at all. Standing at the base of a 495HD's crawler track, a person is dwarfed before even reaching the machine's main deck. It measures close to 30 meters long and stands about 19 meters tall, roughly level with the roofline of a 6-story building. P&H answered Bucyrus's largest shovels with the 4100XPC, refining the 4100 platform into one of the largest standard production electric shovels ever offered for sale, rather than built as a one-off. It went to the same class of mega mines: oil sands in Alberta, copper in Chile and Peru, coal basins in the American West, where a handful of shovels this size can do the stripping work that would otherwise need a much larger fleet of smaller machines. By this point in the shovel's evolution, the limiting factor wasn't really engineering anymore. It was logistics. How do you ship, assemble, and support a machine this size at a remote mine site without a purpose-built supply chain behind it? The 4100XPC's dipper spans roughly 56 to 76 cubic yards, among the largest capacities ever put into a shovel built for repeat production, rather than a single custom order. Operating weight climbs to around 1,600,000 pounds, close to 800 tons, meaning the crawler tracks alone are custom heavy fabrication components, rather than standard parts. Combined horsepower across the drive system exceeds 5,500, distributed so precisely across hoist, crowd, swing, and propel that operators describe the controls as feeling lighter than shovels a third its size. Assembly at a mine site can take a dedicated crew several months, arriving in hundreds of separate truckloads before a single weld begins on the final structure. Once running, a 4100XPC frequently becomes the single highest producing machine at its mine site, sometimes outproducing two smaller shovels combined. Beside a loaded ultra-class haul truck, the 4100XPC's dipper is roughly the size of that truck's entire cargo bed. The machine measures about 32 meters long and stands close to 20 meters tall, taller than most six-story buildings. At the very top of the electric rope shovel class sits the P&H 4800XPC, the largest electric mining shovel ever built, and only a small handful were ever produced. Each one built to order for a specific oil sands mine in Alberta, rather than sold as a catalog item. Suncor and Syncrude needed shovels that could keep pace with mining plans calling for hundreds of thousands of tons of oil sands moved daily, and existing shovel sizes, even machines as large as the 4100XPC, weren't quite enough. Harnischfeger, later part of Komatsu Mining, essentially scaled every system on the 4100 platform up by another step to answer that specific demand, producing a machine so large that most mines in the world have no practical use for one. The 4800XPC's dipper capacity runs up toward 115 cubic yards in its largest configurations, nearly double what the 4100XPC carries, and roughly 60 times the dipper size of the original Bucyrus-Erie 50B this list opened with. Operating weight reaches around 2,160,000 pounds, close to 1,080 tons, making it heavier than some naval vessels. Combined drive power crosses 6,000 horsepower, and the machine's crowd force alone can exceed levels that would tear apart the structural steel of any shovel built a generation earlier. In practice, a single 4800XPC can move enough oil sands overburden in one day to fill several hundred of the largest haul trucks made, effectively doing the stripping work of an entire small mine by itself. Because only a few were ever built and each stays permanently assigned to one pit for its working life, spotting one in person means traveling specifically to the handful of Alberta mine sites that operate them. Look at the bucket hanging off the front of the boom, and you're looking at the single largest dipper ever fitted to a mining shovel. Its opening is wide enough to swallow a small house's worth of material in one bite, and the reinforced teeth on its lip get replaced on a rotating schedule, because ordinary wear would otherwise crack the casting within weeks. Every design choice on the rest of the 4800XPC exists to support swinging this one component, loaded, thousands of times a day. Set beside a person standing on the ground, the 4800XPC's single dipper could hold that person along with several friends without anyone touching the rim. The machine measures roughly 36 meters long and stands about 23 meters tall, taller than a 7-story building, making it the largest thing most people will never get to see move.